Hello, my name is Lindsay Gold, and I'm from the University of Dayton in Dayton, Ohio. I teach the math methods for early childhood majors, as well as the grad level educational technology courses. And tonight I'm here with Matt, and I will send it over to Matt so he could do his introduction. And I think, Matt, you might be muted because we're not hearing you.
That's the game. I love it.
That's okay.
Thank you, Lindsay. Good afternoon, everyone. I am Matt Owens. I'm a master teacher in New York City. I teach at Aspirations High School in Brooklyn, New York. And I also support AP mathematics teachers across the city in the AP for All program, which is a program out of the New York City's Department of Ed's Equity and Access, Office of Equity and Access. So it's all about bringing access with good tools like this tonight to all students to broaden the participation in mathematics.
Excellent, thank you. And today we're going to talk about numbers and operations, specifically patterns, sequencing, and functions, and how these concepts span the grade levels from kindergarten through 12th grade. And I'm going to focus on the elementary part, and then I'm going to kick it over to Matt to do the middle and high school part. I will be using the TI-Nspire app for the iPad, and the concepts that I'm going to be demonstrating have to do with creating basic patterns from shapes and colors, and then finding the rule. So I'm going to start out by sharing my screen here, and this takes just a few seconds to kick over to the iPad app that I'll be using tonight. And you should be seeing some shapes, some circles and squares and triangles that come up. We're talking about shapes and patterns. And so what I do when I'm using these with elementary students is I start by moving some of these shapes around. Now, when you do that on the iPad, to move a circle, you're going to use that point in the middle, and then you're going to slide it down. To move a square, you need to click on the outside and not the interior of the square, and then those will move. And same with the triangle, you're going to click on the edges and not the interior of the triangle, because the actual triangle is the edge on the outside. So I start by moving some shapes around, and I tell my students, okay, I have a circle, and I have a square, and I have a circle, and I have a square, and I have a circle. And I said, what kind of pattern is that? So we talk about the formation of the patterns using the letters. So the first circle is the first shape in our pattern. So that's going to be an A. And then the second shape is the square, which is going to be the B. And because the circle comes next again, that's another A, and then B, and so on. So then the students would identify that as an AB pattern. And I would try another one with them. And to put those shapes back, the fastest way to do it is to just hit the undo button on the left side of your iPad screen. And that moves them back to their original position. And then I would give them another pattern. So I'm going to move the circle, the square, and then another circle, and square, and square. And I would ask them to identify this pattern. Now, we're starting with the circle again, so that's our A. And then we have a square, which is our B. And then we have a second square, which would be another B. So in this kind of pattern, this is an A, B, B pattern. So the students would recognize that since they have two squares, they're going to have to say two Bs. And then I'd send that back. And I do one more with them here, moving circle, square, triangle, circle, square, and triangle. And in this case, we have the A for the circle, the B for the square, and a C for the triangle. So this would be an ABC pattern. Now, the next thing I would do with the students is I would give them the opportunity to create their own pattern. So say I want to do an AAB pattern. Matt, what would you like to see as the A? Would you like a circle, a square, or a triangle?
You're trying me, so I'm ready for the triangle.
That sounds good. So this time it's fine. Like we can make anything our A as long as we're consistent. So we're going to use the A for the triangle, and we set an AAB. So I'm going to put 2 triangles. And Matt, what would you like for your B?
Let's take the square.
Perfect. So then if I was asking the students to do this, I would ask them to do a series. So not just one AAB, but I would have them create at least 2 in the series there. So then I would go through this again with the students where they have the opportunity to make their own patterns. And they'll like that because then they have some choice, and choice is always good when we're working with our students for this. Now, the next thing I do with the students that is fun is it's like a guessing game. What shape would come next? So I'm going to start here with this circle, and I would ask the students, okay, what shape do you think will come next? And they could say anything. I mean, they could guess anything because they have no idea what I'm thinking. And so say they guess a triangle, and say, nope, it's not a triangle, guess again. And this time they guess a square. So yes, that's right. So then I move the square and I say, now, what do you think will come after that? And a lot of times, you know, they'll guess the triangle because they want to see all 3 of them, or they'll guess the circle again, like an AB pattern. And I'll say, yes, that is correct. It is a circle again. And then I like to really mess with them because I'll say, okay, what do you think the next shape is? And they think they got it. It's an AB pattern, and they'll guess square. And I'll say, nope, it's not. It is a triangle. So now they're having to think a little bit. What is she doing? Where is she going with this?
Yeah.
Yeah, exactly, right? And so the next shape actually then is going to be another circle. Matt, do you have an idea what'll come next?
A square.
I think you're right. Let's move a square. And then next, how about a circle? And then what's the next one, or the last one in this case?
In this case, it would be triangle.
Right. So to them, they're like, ooh, that's a new pattern. So I would ask them, okay, now that we have these shapes, what kind of pattern is this? And they could recognize that there's an A and a B, and then the A repeats, and then we go C. So this is an A, B, A, C pattern, which is always kind of fun. When I was teaching 1st grade, I used to do this activity before I had this technology. I would use my calendar time and use translucent shapes to put over my calendar numbers. And that's what we do it every month. We would have a new pattern kind of thing, which was always fun. The students always enjoyed that. So talking more about the iPad app real quick, on the left-hand side, you'll see some icons. That first icon under DEG is what pulls up our menu of pages here. So I'm going to go to the next page, and you're going to see some books. These are just some books that I found and enjoyed working with my students, especially the last one, The Keeping Quilt by Patricia Polacco. And this picture you see here is actually one of my grandmother's quilts. And I would show them, okay, what kind of pattern are you seeing here? And if you look closely, there's like 2 darker blue flowers, and then you'll see 3 lighter blue flowers. And you can kind of see how that goes around in the pattern. And so I'm trying to show the students that you see these patterns in everyday life. You'll see them out in the world around you, and you need to start recognizing those things and everything. So they always enjoy looking at the quilts. And from that, then we talk about making our own quilt. And I want to give a shout out here to the master, John Hanna, who created this next part for me. He actually created it for a presentation I did for the international conference in 2018. I was actually, when I was presenting at the TI conference there, I was talking about fractions, percents, and decimals. But what's awesome about this application that he created is I can use it for things like patterns as well. So thank you, John, for that.
Wow. Yeah.
I know, right?
I can already see it now with just the pattern you already have with 7 in a row. I can already kind of imagine. Oh, wow. This is great. Go for it, Lindsay.
Exactly. So the default on this is like a 10 by 10, but you can go and click on that wrench thing, which is the tools, and you can change that grid size. And there's a variety of things to change from. For this next section, I'd like to do a 5 by 5. And to see how this application kind of works, at the bottom of the screen, you'll see the colors, and students can click on those colors. And if you notice, it's real light, but there's a thin line above the grid that changes as I click on those colors. So that way the students know what color they're on. So I tell my students, okay, now it's your turn. You're going to be able to create your own quilt square. So we will go ahead and we will create, and they can do whatever they want. They have to think about the patterns like we talked about, A, B, A, B, C, whatever they want to do. But they need to fill in the squares. And to do that, you touch on a color and then touch on the square. It's very, very nice and simple like that. So color, square. And then they can design their quilt square however they would like. And this is where, see, I'm a big STEAM person. Like I'm all about, you know, the science, technology, engineering. And the A, I like to stick the A in there, which is the arts with my math, because I teach math, but I'm constantly teaching in a STEAM type environment. Yeah. So I like to give students that opportunity to be creative, because I personally like to do this kind of stuff too.
And then Lindsay, we know what big ideas are coming at the end of middle school. So this is a great way to segue into area.
Exactly. And so that's what's so nice about this series that we're doing on these webinars, is that you will get to see how that progression is made. And it's important to know that as teachers, where they're coming from and where they're going. Yes. So definitely. Okay, so here's my quilt pattern. And Matt, can you identify that pattern?
Blue, green, BG, BG, AB, AB, AB.
You got it. Excellent. And so what we would do is all the students will have their iPad out and they know in their head what their pattern is. And then the other students can go around and do what we call a gallery walk, where they get to look at the other students' artwork, and then they can identify the patterns that they think that student was using, which is nice.
And Lindsay, that's also a great surface for that mathematical practice of constructing viable arguments and critiquing the reason of others, just for them to involve others and share their whole entire quilts and try to guess the pattern and validate it is just strong enough for that early grade span. That kind of with the talk in mathematics.
That is a great point. That's a great point, Matt. Anytime we can get those practices in there is awesome.
Yes.
So then I'll go to the next screen, and this is a 10 by 10 grid. And I'll tell them, okay, I'm going to make a pattern, and I want you to kind of see if you can guess what I'm doing here. And so as these colors, or this particular color starts to show up, I ask them, okay, what do you see that's going on here? Do you see any like patterns, recognition? You know, what's kind of, whoops, I did not want to do that. And hopefully, you know, if they do that, they might say, is that really where you want that?
Yeah.
No, I want it over there. So hopefully what they would see here is they might be able to say, I see a diagonal. So it looks like you are making diagonals across that 10 by 10. Yeah. And other students might see this as, well, it's like white, white, blue. Like you were talking about, Matt, with the last one, you were identifying blue, green, blue, green, blue, green. So they might see the white, white, blue, white, white, blue. So they could even say, well, this kind of looks like an AAB, AAB.
Yes.
And as teachers, what do we a lot of times equate with a 10 by 10 is, and we're going to tie this together in just a minute, but a hundreds chart, right?
What other way to link it?
Yes, especially in elementary, we love us a good hundreds chart. But what's great about the hundreds chart is the patterns. So I asked the students before I talk about anything, what kind of patterns do you see here? So if you're out there in YouTube land and you want to throw in a chat, some kind of pattern that you see going on there that you think your students might recognize, or whether they're looking at columns, rows, diagonals, anything like that. There's lots of different things out there. So feel free to share as a community what kind of patterns you see. But one thing that I always try to point out to the students, and really one thing that they identify, is with the columns. They're like, oh, that number always ends in 1 or 2 or 3 and so on. And then they'll see the rows. And we talk about, okay, so you have it looks like that row is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the next row, 11, 12, 13, 14, 15, 16, 17, 18, 19. But then teaching first grade, here we are teaching first grade, they'll be like, what's that 2? Why is that 2 there? And so we talk about, the tens, and it leads into counting by tens, those kinds of things, those benchmark numbers, for them to better see that structure. So on this hundreds chart here, what's really nice is I can click on a cell and I can click on up towards the top underneath add, and beside the tool, there's like 3 vertical lines and 3 dots, and I can change that fill color. And I would like to go through here and change that fill.
So you're now creating a little hundreds board quilt.
You got it. So we are creating that same pattern that we just created on the last 10 by 10, but this time we're equating it with numbers. So that is always nice. Yeah. And they start to recognize, oh, now not only am I seeing diagonals, but I'm starting to look at the actual numbers.
Yes.
And they get pretty excited about that. And I won't go through the whole chart, but I would start, to ask them, okay, what kind of patterns are you seeing? What are you recognizing? And then I take it a step further. And over on column L and M, you'll see steps and values. And here is where I would enter the steps or the series. So if you double click on those cells, you will get your keyboard to pop up. And then to get your keyboard to go away, you can click in the bottom right-hand corner and that sends it away. But I'd like to fill in some of these numbers here. So I can type 2, enter, and it takes me down to the other 3, 4, 5, 6, 7, 8, 9, and 10. And then I'm going to hide that keyboard for just a minute so they can see here. Okay, so what was the first number that was shaded blue? So Matt, what's the first number shaded blue?
The first one in numerical order would be the number 3.
You got it. So I'm going to hit 3 and enter. And the second one, Matt?
6.
Awesome. And the third one?
9.
Good. And so here's where I kind of stop for a moment. And I'm like, do you recognize anything? Is something happening? So the fourth number would be?
The fourth number would be 12.
You got it. And then fifth number?
15.
Sixth?
18.
Right. Seventh?
21.
And eighth?
24.
And ninth?
27.
And finally, 10th.
30.
Excellent. So then I would look at this with the students really closely. So now you've identified the first 10 numbers. Let's look at the values. What do you notice about those values? So in the chat, if you're out there in YouTube land and you'd like to pop in a little saying, what do you notice about those values? How are they changing there in column M?
Yeah.
And the students they get really excited.
They do.
They start to recognize these and they're like, oh, I think I got it. I think it's almost like a puzzle to them. It's like, oh, I think I got it. I think I know what she's trying to do there. And I always encourage them, look back at the hundreds chart, take a guess, predict, what do you think the next number would be? Why do you think it would be that? All kinds of things there. So looking from 3, 6, 9, 12, I'm hoping that the students will recognize that we're adding 3 each time. So each time we go up a step, we're adding 3.
Yeah.
And so then they get real excited about that, and we can predict then throughout the whole hundreds chart what that's going to be. But what's nice about this is this kind of leads into what is known as an input-output chart. And so those are the exact same numbers we have here, but then we start to look at what do you have to do to the input to get the output. And so this is when students have to go a step further and they start thinking about these two columns and how they're working together. Yeah. So looking at the input 1, we went from 1 to 3. So we could take some guesses, maybe it's add 2, maybe it's multiply 3. I mean, there's things we could do here. We look from 2 to 6. If it was add 2, that would be 4. So that's not it. So it's not input plus 2. So let's try that input times 3. And does that hold true? And in this case, it does. And then we could look at the next part, which is a 3. And if we take input times 3, does that hold true?
Right.
It does. So this way we take the students away from having to list all those out, and we start to say, okay, now without listing them out, what would be the 20th? If the input was 20, what would the output be? And we'd hope here that they'd say, what, Matt? If the input was 20, what would the output be?
I would hope they would say 60 because 20 times 3 is 60.
And I would hope so too. But if not, we would go back and we do some reteaching and we do some more modeling, and we would show them again, because that is what is so important, is to make sure the students see the mathematics, they understand the mathematics, and they're not just memorizing the mathematics.
Right. Lindsay, could you back up to the other screen prior to the hundreds board, because there were some valuable comments from the chat. I know GoVG Major said that concepts that could be brought up here could be even and odd numbers. And again, if you were to make the 2, 4, 6, 8, and 10 even numbers, you would get kind of like the same step values, but you will see probably an increase by 2. I love it.
Exactly. That is a great comment, because even and odd can be difficult, especially at that early elementary level. They kind of struggle. What do you mean even? What makes an even number and an odd number? So they could see those patterns. That is a great comment.
Yes.
Yeah.
Oh, awesome. Great way. And I mean, this is the primary grades and giving kids that access early. I love how you started, Lindsay, in just early grades with just a pictorial approach. And then you went to the spreadsheet, which was, a lot of times in secondary grades, we're concerned about 2 variables. But just to think about the spreadsheet spreading and expanding to become a hundreds board is another way of looking at multiples, add-ins, a lot of concepts here.
Right. That's why we love us a good hundreds chart.
I love how you started with the 5 by 5, and I was like, wow, if we just had 3 more of those, we'd be down at the hundreds board. So we're good.
That's right. That's right. Well, Matt, I am going to send it back over to you here by stopping sharing my screen, and hopefully you'll see me again and Matt
Yes.
you again. Yeah, I'm back.
Thank you, buddy. And we want to give a shout out to Bob Peterson from Mount Vernon, Washington. Great to have you this evening. I like where Lindsay stopped the story. A lot of times in the vertical articulation series, we kind of know where students are and what students are learning during that grade, but it helps to know how the story was built prior to the grade that they're currently in. And so, Lindsay, I applaud you for the different representations you use. But I'm going to actually start at where Lindsay left off. And Lindsay, I am using the TI-Nspire CX teacher software, and I'm going to open a list and spreadsheet. And again, Lindsay, you were using input and output. I'm going to do that. I'm going to call this the input and output. And if I recall the values correctly, the first blue, the second blue, the third blue, the fourth blue square, and the fifth were 3, 6, 9, 12, and 15 respectively. Okay.
Matt, should we be seeing your screen at this time?
I apologize.
No worries.
Okay.
There it is.
Okay. For those, I apologize for that. In the teacher software for TI-Nspire CX just to show you where I was, I am using a list and spreadsheet, which is where Lindsay's hundreds board was constructed across 10 columns and 10 rows. But I've already started inputting the values. So in the secondary grades, we're really trying to look at that relationship, look at that rule, and kind of discover the algebraic phenomena behind why these outputs are coming from a direct relationship, in this case, with the inputs. And so what I love about the Nspire software is it allows the students now, at this point, we've modeled, we've gathered the data, we've modeled it with different pictorial representations. And now here, we are at a place where we can model this data and see what kind of correspondence is here. So I've given my columns a name, input, output, and I have the values there. I could enter more values, but in this case, I think this is enough. So what I'm going to do is do a little bit of model. So I'm going to add a page, a data and statistics page. And here you can see that these 5 points that you see here, these are the 5 rows that I kind of declared from the input output. And when I hover over these points, I'm getting a direct meaning. So I love that there's reasonableness and meaning to the points that I have here. So let's go ahead and organize the model. The independent axis, of course, will be the input, this is something they discover in early grades as early as grade 6 and 7 in middle school. Okay. And then
I love when those dots start moving.
I love those dots.
There's
right?
something satisfying about that.
And then on another series, later on in an upcoming series, you'll know how these dots can actually promote statistical thinking with dot plots and other things. But in this case, I'm going to go ahead and declare the dependent variable, which will be output. And voila. This is what we have here. This is very powerful. And I love now that the axes are labeled. But the beautiful thing about this now is I know that this point, the third blue square, 3, 9 corresponds to third blue square, and the number inside that box was 9. So this is a great way, Lindsay, to lead into a big idea in secondary grades, which is the concept of a sequence. And the Common Core was probably the first series of standards to bring to high school the purpose of sequences defined as a function. In particular, two popular sequences, the arithmetic and the geometric. And in this case, in middle school, where the linear functions is really the heart of the algebra in middle school, students are exposed now in just this task, Lindsay, to middle school concepts. I'm actually hitting regression. I'm actually hitting modeling and trying to trap this data to a meaningful expression. So I love how Lindsay asked earlier, everyone, well, what would be the 20th term, Matt? And so this is a great way to have students to model. The beautiful thing in this environment is that students, if I click on menu, followed by analyze and plot function. A lot of times in middle and high school grades, once the data is here, some students jump directly to a regression curve to look at a particular model that could be retrieved here. But in this case, I like in the early grades in middle school, if students can kind of discover that. And I'm going to use the plot function. And so here is a great way to bring into conversations linear growth. We are now looking at slope. And I really like the fact that these points, I can bring up rise over run to look at these triangles that are formed here. It's a lot of mathematical phenomenon here. I know that I can rise 3 and run over some more, 1. And so we can look at those successive ratios as well. But in this case, with the plot function, what I love about this is hopefully in middle school grades, kids will understand that the slope of this kind of like linear progression is 3 times x. And you might say, well, is that it? Well, this is a great time for the kids to discover in those early grades. If I press enter, boom, that lands right on target, right, Lindsay?
Yes, that is beautiful.
That's beautiful. And so again, we're at a place now where I can bring in some big ideas here. I can get kids to really interpret what this 3 really means in the context of this problem. So Lindsay, I love how that table was vertical and you were looking at the differences. So we can bring up the idea of finite differences here. And knowing that the slope of this line is really the difference between the outputs over equal input intervals. So 6 minus 3 divided by 2 minus 1 would be the same quotient successfully with that difference quotient. This is a big idea in high school with average rate of change and slope, okay? I love this example. I love this example. So again, I could have used the plot function to get kids to discover that. And then another thing I could have done, I'm going to press escape. I could have done an analyze and I could have modeled a regression equation for linear. And again, that I love this part because now students are kind of like mathematically validated. You know, I was guessing that it was 3x and now, you know, the actual value is 3x. And then we can bring up big ideas like correlation coefficients here. I'm quite sure it's going to be a nice R equals 1 because these points go directly through those blue circles. And again, looking at big ideas of interpreting coefficients, those FIF standards in our states where students are interpreting what this 3 means in the context of the problem. It really means every third cell in that hundreds board contain one of these values here. So, and I love that the y-intercept in this case has a meaning of no particular value in this case was declared originally. Okay, awesome, awesome, awesome. To move on, and again, you saw how that activity just came right from Lindsay's, directly from Lindsay's elementary primary grades, and that same task can evolve across secondary grades. In the chat window, my TI friends are going to post a link to the Mathematics Vision project. I want to show a task that could be done in early as grades 6, 7, and 8, and definitely could be done in high school. And it's called the growing dots task. In this case, the growing dots task is a task where students are engaged with looking at a progression of dots in that pictorial pattern. Again, going back to Lindsay's practice of multiple representations, this allows a chance for students to really see how this progression builds. In this case, we have 3 different declarations here at the beginning, at the first minute, at 2 minutes. And I love this task because the independent variable is based on time, which really has a lot to do with change because something is changing at every particular minute interval. So we have 1 dot at the beginning, 5 dots at the first minute, and it looks like we have 9 dots at the second minute. In the chat, I want you to think about how many dots would be at the 10th minute. In the 10th minute, how many dots would there be in that particular stage of the progression at the 10th minute? Okay, so Lindsay, I love how the idea of that pictorial representation is still there. I like how the students have access here to the dots. This is a great time where kids could use those color counters to actually model and probably rearrange the figure in a way where it makes sense, because I've seen this happen with this particular task as well, as we see it coming in. And again, it's the same thing again, input, output. So in this case, I am looking at the beginning as probably like a t equals 0 moment. And at the first minute, I'm looking at probably like time being 1 minute and 2 minutes time equaling 2 minutes. So with this progression already, again, kids could do just what you did, Lindsay. Play around with a little bit, see what's going on with the sequence. And again, I'm going to start that correspondence again. I'm going to, the beautiful thing about this task is I actually brought in an example of what the dots would look like at the 4th stage of the progression. So this is a great way to kind of make sure all students have equal understanding of the concept before you ask for that generalized or that further stage, like the 10th one that I'm asking. So in this case, it looks like at the beginning there was 0, this 1 dot, and then the beautiful thing I love about these concentric squares is it really shows that progression, that 4 dots are being added at each particular progression of the stage, okay? So again, here's another sequence where the terms are successfully increasing by 4 in this case. And I love that geometric understanding. Again, Lindsay, I'm looking at 4 corners. So this is a great way for students to kind of really bring meaning to that 4 in terms of vertices.
Yes, I really like that visual, Matt. I've seen dot things like that before, but I really like the way that's laid out and modeled.
Yes, yes, yes. Thank you, thank you.
Yes.
So I'm going to actually keep the same input output, but this time I have a different meaning here. I'm going to start at the beginning. That was time 0, time 1, time 2, and then we were good at time 3. Okay, and then I'm going to delete the others. Something I want to show you as before I enter the output. The thing I love about the spreadsheet, so Lindsay, you taught me something new tonight about the whole hundreds board. I'm looking at how I can teach factoring tomorrow with trying to find multiples and things with that, just with the spreadsheet.
Okay. Absolutely.
So I love this Nspire because, again, this arithmetic change, this arithmetic sequence, Nspire is grounded with it. If I highlight all of these cells, not the cells heading, but if I highlight this and I was to extend it, again, I'm extending the cell. It almost goes back, Lindsay, to extending the rule. So if I want some more successive cells, I can stretch it down and it will fill in all of those cells in between. So at 0, there was 1 dot, and then 4 more corners of a square was around that dot, which made 5, and adding 4 more made 9. And what I love about this is even if students have a little inkling of an idea, again, I love that this allows them to grapple with that whole idea of change and extending it. I love this. And I'm just going to delete this. And my task was how many would be in the 10th stage of the progression. And if I go there, I can see here, if I go back to my model, now things change. And I intentionally did this because my input output still remained the same, but now my regression equation is totally different now. So now if I go with a plot function, I love that feature. If I go with a plot function, I know at time 0, there was 1 plus 3 times x. No, in this case, not 3 times x, 4 for the corners, right? 4 corners.
There you go.
Yeah, yeah, yeah. And so it went somewhere. And so now we can see that particular pattern. And again, it's there. And I love that R squared there to let us know that it's truly a strong correlation. This equation, 1 plus 4x really matters. And I love what 1 plus 4x really represents. It really represents that first dot. And we're adding on X amount of 4 dot groups per stage, and getting kids to really interpret the meaning of this would be phenomenal, which is really what we want them to do with the standard of interpreting the parameters of the linear function. Now, before, I know we're getting short on time, but there's some other good, juicy parts of Nspire that I wanted to highlight here that will show up in high school. Again, in high school, the standards have really evolved to exposing students to recursive thinking. This is a really big idea and can be kind of complex for students. A sequence that really depends on previous terms or a previous function there or function rule. So in this case, I wanted to really, the title of our series tonight is Numbers and Operations. I did not want to neglect the calculator page. There's power in this calculator page. So a sequence can be defined here. And when the Common Core came out and I was looking at the articulation of the standards, I kept asking myself, why would you want students doing piecewise functions so early in grade 9? And then I had an aha moment here. And these are all nuances as we teach the standards. I'm going to define, in this case, U of n, in this case, to equal. And here, if I click this catalog key beside the number 9, and I use piecewise, this is a great way to kind of build a recursive function off of the first term and a rule for successive terms after that point. So maybe for the first term of the sequence, I want 5 to be my output. The first term would be 5. So in this case, n would equal 1. So my first term would be 5. And then let's suppose that every term afterwards would be 5 plus 4 times u of n minus 1. In other words, every term afterwards is going to be defined by adding 4 each time. And I want to declare this for any n. In this case, I'm going to use the test command by pressing Control equal, greater than or equal to 1, and voila, I'm done. The beautiful thing I love about this, Lindsay, your chart from input output is really about to come out now, not verbatim, but if I look at u of 1, I've now declared this recursive function is 5. U of 2 is 25. I really didn't want that. And then u of 3 in this case, hold on 1 second. In this case, I want to do 5 plus. I want to do the first term to be 5, and everything thereafter would be u of n minus 1. So in this case, I'm done. But again, I know that u of 1 is this. I know that u of 2 will be this value. And again, the thing I love about this is I'm now getting, I'm using multiplication, but I hope that we're starting to see something here. Okay. I hope that you're starting to see that this is a geometric progression where every successful term is not coming from adding and subtracting. Every successful term is coming from a multiplier of 5. So 25 divided by 5, and so forth and so on. So I'm getting a whole different progression here. So this sequence is kind of defined kind of weird, but at the end of the day, in this case, you can define these sequences in terms of one term and successive terms afterwards. Okay, so I definitely wanted to show that piece. And one last thing, because I know we're at the end of time, something that is very eye-opening for high school students. We're so used to graphing functions, but in this world, for sequences, I now can do that in this case. I can graph sequences where maybe my first term is going to be 5, and I can declare something like 5 plus n. And again, now we have that graphical view. Kids are now starting to see the actual linear progression. And again, we also have those multiple representations to support the understanding as well. So I'm going to stop it here, Lindsay. Again, I love how all of the concepts of patterns, it just didn't start in high school.
Exactly.
It didn't start in high school. Yeah, so thank you, John, for the recursive. Yes, so thinking about that recursive as the piecewise, that is phenomenal. So a great way to kind of sedge the piecewise function, which is a really abstract topic for students to see how can a function be defined in 2 or more ways in one function. It's kind of very interesting, but it brings a nice concrete model for them with sequences.
Thank you, Matt. That was a great example. And it's so nice to see this modeled in a way that the students can visualize and manipulate and understand versus just memorize. Yes. So that was a great progression with our patterns and sequencing. Okay, so it doesn't look like we have any final questions. So Matt and I are going to sign off for tonight. We thank you for joining us, and we will be back next week again.
Thank you. Have a great night, everyone.
Thank you.